Please, no applause,
Thanks.
please. Cool. All right, thanks. I feel like we've been up here already today.
Yeah, this
Weird.
room seems really familiar.
Yeah. Thanks for coming. I'm Joe,
I'm Zoz.
and we are here. How many of you guys have seen Prototype This before? Yeah? Good, okay. So
Cool.
five of us total. That's not bad. I think
We're-
10 in total everywhere, probably.
We're really excited to come here and present this for the first time outside the United States because Belgium is actually the first place that Prototype This aired internationally. When it went international, it started off in the US, and when they rolled it out, for some reason they started it out in Benelux, which is Belgium, Luxembourg, and I guess the Netherlands probably.
Yeah, so pretty cool. So yeah, what better place to give our first Prototype This presentation? For those of you guys who don't know, Prototype This was basically 4 guys building crazy electronic things, crazy prototypes, and we have lots of stories to tell. This presentation is mostly, it's some of our favorite projects, but also a lot of behind-the-scenes stories and bitching and stuff. So you get to see what it's really like to make TV.
Yeah, we made a lot of jokes about the nature of the show, but one of them was that it should be called Complicate This, because every time we come up with an idea, maybe it was pretty elegant, and the networks would say, well, you got to have more electronics, and you got to have more, robotics and
More
stupid
fire.
stuff, which, we were glad to do, but definitely means that some of the things that we built ended up being much more ridiculous than they needed to be.
Yeah, sort of the goal of the show really was to show this engineering process of concept and prototyping and failing and hopefully succeeding at the end. But it actually, and it sort of was that, but there was a lot of stuff, yeah, like Zoz says, that we wanted to be in there that wasn't because it wasn't sexy enough maybe. But we had to do a lot on our side other than just being hosts of the show, but also educate the producers about what real engineering is, because they're focused on making television, and most television sucks. So we had to sort of show the process to them so they actually knew how to properly make the show, which was sort of nothing that we had expected. Neither of us had really done TV before. Well, Zoz had done an awesome show, UFO-related show, but nothing like this. So the show aired in, 2007 in the US? Is that what my slide said?
I thought 2008 was when it started to air.
Yeah, 2008 in the US, and then February 2009 in the world, so you guys were first. And now it's on Netflix, and I've heard that Belgium just recently got Netflix. Is that true? Yeah. So I don't actually know if it's available streaming. It might be internationally, but in the US it was only available on DVD. I've heard it's also on the Pirate Bay.
I've heard a rumor to that effect as well.
Yeah, I've never visited there, but I've heard it's there, so maybe you want to, check it out. Let's see, so some of the episodes, we built a lot of stuff, and sort of contrary to popular belief, when you're on TV, you don't become instantly rich and famous and have lots of money that you can spend on building projects.
So as an example of how the production company that made this really didn't understand anything about engineering. They basically forgot, when they put in the proposal to the network for the show, they forgot to budget for the engineering part of it. So they just kind of felt like it wasn't going to cost any money. So they kind of scrabbled together, after it was approved and everything, and they realized things were going to be expensive, so they scrabbled together $12,000 per episode, which covered all engineering. So all parts, all shipping, all, if we needed any technical outsourcing work to be done. That was everything.
Well, the most of the budget was, I think, filming, production, and film was like $100,000 a day or something for cameraman and soundman or something. It was a lot, and it definitely wasn't our salary. But that, it was part of the challenge for us, because we're hackers. We're both hackers. The other guys on the show, I'll talk about them in a second. We come from the background of scavenging for parts and, hacking stuff and making things work no matter what. So saving money wasn't really an issue for us, but it was like we were really limited in what we could actually do because we couldn't get certain things that we needed. We were actually pretty good at calling places and saying, hey, we're on TV, can you send us parts?
Yeah, that was the best skill I think I developed out of the show, was the ability to talk companies into giving me free shit.
Yeah, especially because they didn't actually get to realize that their shit wasn't really shown on TV until after they gave it to us and the episode's already aired. So it was, good scam. So we didn't have a lot of time and money. We had 2 weeks per episode normally to film. Some of them got stretched to 4 weeks, 5 weeks, but that was like really, we were like begging the production company to just let us try to do it. Because really they wanted us to build things that had never been done before on TV, and were great and huge and gigantic and spectacular. And if you do a Google search for pretty much anything, somebody somewhere has done it. Or on YouTube, you'll see, something. So to come up with projects that really were interesting and fun was hard, but then we also wanted to try to do stuff that actually was like practical and not completely ridiculous. But some of those ended up being completely ridiculous. Okay, so there was 4 of us on the show, and I was the electronics guy. I was one of the last people to join, and you were one of the first of the cast.
So they had asked a few people to do it in the first round, of which I was one, and Mike was one because they knew him from another show that he'd been on for Animal Planet. And almost everyone said no, they didn't want to do it because it was a lot of MIT people, and the contract that they first offered was really crap, and no engineer would ever sign it. And so they were, I guess, really surprised that a lot of people turned it down. And so we did a second round, and Mike and I were involved in that process, and we had a chance to say, this is the kind of people we need. And we said we need like a really good electronics hacker, and we need like a special effects guy because they know how to build lots of mechanical stuff really quickly. And then when the resumes came in and I saw motherfucking Kingpin from the Loft on there, I was like, hell yeah, this is that guy.
Hell yeah. And yeah, so it turns out that we didn't know each other before the show, but we knew a lot of the same people and went to a lot of the same conferences. We just never met. So it was like, the first day we met, we went out to dinner, and it was like, oh, this guy, and I worked with one of his friends. It was just a totally weird connection. So they actually did a pretty good job of casting, I would say. But yeah, it was just a weird, like by the time I got involved, part of the contract, which a lot of people didn't like before, which they had changed, is that now we as the talent got to own what we developed. So we owned the intellectual property of the projects, as opposed to normally, like if you work at a company, they try to own what you develop on company time. The production company didn't want, at that point, they didn't want anything to do with owning the projects. And it could have been a good thing if we had better business sense and just, more time and more money, we could have tried to productize a lot more of this, but we didn't. And a lot of the stuff that we actually worked on ended up getting thrown out anyway, which is sort of a shame, except the stuff that we salvaged. So I did the electronics on the show, and of course integrated, whatever electronics I had with the stuff that Zoz was working on, which
so there was a real kind of tendency on the part of the production people to try and stereotype the characters so that they can be like really easy and understandable. So even though I do a lot of stuff in the machine shop, I was the only one really writing a lot of software for the show, so I became the software guy and the kind of robotics guy. Anything that really took place with mechanical hardware, no matter who actually built it, tended to get sort of filmed as though someone else built it.
Yeah, the magic of television. So then we had Mike North, who's a material science guy and mechanical engineer. This was his first job out of college. He'd been in academia and then, after grad school or whatever, he got his PhD. So Dr. Mike North, first job out of school was to be a TV host, which is sort of going downhill, I think. So it's sort of interesting to see his perspective. But he was basically the guy that would do all the shit that no one else wanted to do.
Yeah, Mike was really useful for us on the show because he was the guy who was able to fill in the cracks and figure out how to do things that we didn't already know how to do. But that also meant that he got absolutely screwed with respect to screen time. So anyone who watches the show is basically like, what does Mike do? And it's because Mike was doing a lot of stuff sort of behind the scenes and figuring out how to, for example, make the legs of a 6-legged robot that could carry 500 pounds in weight and stuff like that.
Yeah, it was a lot of stuff that just unfortunately just wasn't sexy, and it was hard to sort of pigeonhole him, right? For us, it's like, oh, nerds, like electronics and software, and Terry like uses machines. But so Mike was sort of stuck in this kind of no man's land of doing all the stuff that wasn't as sexy. And then Terry Sandin is a special effects guy from Hollywood, pretty well known. He's done a lot of special effects on some pretty large films, and came in and super talented. Just operates out of his head. And I think like the rest of us, sort of type A. So he liked to work on his stuff, and then we would work on our stuff separately, and then we would combine our stuff together, and then try to combine it in with Terry's. And sometimes it worked, and sometimes it didn't. But he wouldn't write anything down and just sort of build stuff. So it was hard to replicate, as you would see on some of the shows. but pretty amazing.
Yeah, I've never really worked for a big corporation, but I can only assume that this situation was really a microcosm of what must go on in large organizations, where you have in an organization, you have small groups working independently on these things, and then when they try to put everything together, it's a complete disaster, and the documentation isn't right, and that's basically what it was, except for it was like 4 people plus the production team doing this stuff. So really the only technical integration that went smoothly was between me and Joe, because we knew the same kind of stuff and we were in the same room, and we had all our stuff kind of aligned well, but then when we tried to integrate it with everyone else, it was just a complete shit show.
Yeah. So contrary to popular belief, there are lots of people behind the scenes on TV. So, when you watch, I should mention too, the production company is Beyond Production, same production company as Mythbusters. Have you guys seen that? The same 5 people? Okay, good. I don't feel so bad. So same production company as Mythbusters, and they had originally wanted to, try to make Prototype this the next success sort of thing. But, when you watch a show like that, you see, or like ours, you see the 4 guys as like the main talent, or you see the Mythbusters people as the main talent, but you never see all the people working behind the scenes to, the camera crew, the sound guys, people running around getting equipment, just all sorts of stuff. It's not, it's not like you have a personal butler, but there's a lot of people working and doing stuff that needs to get done. So there's all sorts of other people. We had some guys on the show that sort of got screwed because they were actually doing more work than we were at times, but never really got the credit of that. So that's sort of, I feel like they deserve credit. Got to expose got to open the TV kimono sometimes.
All right, let's see if we can move on to some projects.
Yeah. Okay.
Next?
So we talked about the challenges already.
Yeah.
All right. So we have like 4 or 5 of our favorite projects. So first one, giant boxing robots, 10-foot robots that were pneumatically controlled that would fight each other based on the movements of players outside the ring. Sort of like, did you ever see the movie Real Steel? Yeah? Okay. Apparently that was based on this episode.
Yeah, I really feel like we defined the giant boxing robot genre, because we did this in 2007, and subsequent to that, there's been a lot of it come out, but we really made it happen first. And this was actually, I was against this project at first. So we shot a pilot right before Christmas in 2006, and it ended up being a non-airing pilot, and we got together to do our first like real episode. And Terry really wanted to do these boxing robots, and he wanted to do it because it was total comfort zone for him, right? Because this is exactly the kind of stuff he does all the time in the special effects world. And I thought, it seems kind of boring. It's not, to me, not very exciting robotics, not really complicated. And so I kind of argued against it. But I was really glad later on that it got shot down on that, because it ended up being really cool. And we ended up, as I said, I think, I would say defining the giant boxing robot genre. And it really sort of let us figure out who each other were and how to work together on that first one. Yeah,
it was wild that was the first one. We should mention, since he mentioned the pilots, most people don't know about this, we filmed 2 episodes that time. One was a robot that was like a pooper scooper robot, so it would go around your backyard and pick up your dog's crap and then fling it, using a thermal imaging camera, and then fling it into your neighbor's yard.
It was super cool. It also had like an electronic nose, so it had some like $10,000 smell sensor that had just come on the market, and so it would actually be able to tell the difference between shit and non-shit.
So you basically train it to smell the shit, like a fingerprint. That was actually one of the more practical ones. And we also did an unstealable bicycle, which now you see all sorts of stuff on Kickstarter about, bike alarm systems and all sorts of crap. But this one basically had an alarm system with GPS, and it was RFID enabled, so you had your little RFID tag. And when the thief would steal the bike, if the alarm was armed, he would ride off, and the steering would lock, and the pedals would lock into your feet, so you couldn't, get out of it or anything. And so then you'd fall over, and then the system would, using a GSM cell phone module, call the police. And with the speech synthesis module I designed, say, my bike has been stolen at coordinates, blah, 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 come get me. And then it would also send a text message to the owner saying, bike has been stolen. So totally ridiculous. And we had a lock that would spray like some
skunk
spray at them. Yeah. So those never made it. But yeah, anyway. Okay. So the boxing robots, there's a bunch of different stuff that went on. And it really was Zoz and I working on kind of control.
The main thing was we wanted this to have a natural interface. So we had these giant robots, but we wanted it to be controlled by a player that could shadow box and do boxing movements to dodge and weave with the robot, and then throw real punches that the robots would throw. And so that would be really straightforward to do with an off-the-shelf mocap system. You could just go and buy a Vicon or a phase-based system and just do that, but we had no money. So we thought it would be fun to try and implement something really bare bones and stripped down that would still satisfy that functionality.
But we did get to try the high-end motion capture stuff, which is why, so Zoz is the Black Knight, and I'm the Rhino. So we got to try the stuff and demonstrate, you know, what high-end motion capture is like, and then it's like, well, we don't have the money, so we have to implement it our way, which ended up being pretty cool. For the boxing part, for the punches, after going to the gym and learning how to box, supposedly, we used wireless reference design from Freescale. So Freescale Semiconductor Company, they had a board that had a 3-axis accelerometer on it and wireless functionality, so just RF, you know, transmissions back to a receiver. So we basically just strapped this reference design onto gloves and then passed all that data over to Zoz, who actually did the processing to determine, you know, what was a punch versus what was an uppercut. That was probably the easiest part.
Yeah, and at this time, Joe was designing the DEF CON badges, and so he was using Freescale processes on those. So we were really tied in with Freescale, and they would come and visit us every week or so, and they'd, you know, show us all their latest reference designs and stuff, and just give Joe access to all that stuff.
That's right, yeah. So I always say in a lot of my classes and stuff, it's like engineers can pretty much use whatever, but it ends up being whatever vendor like schmoozes them the most and takes them out to lunch and gives them free stuff.
Just like your doctor.
Yeah, exactly. Okay, so then the second part, we had glyphs on our back, so icons for augmented reality, which might even be the first time that AR was shown on TV.
Yeah, I'm not sure. I had been to a conference the year before where people were doing some rudimentary AR toolkit stuff. And so when we started talking about how we're going to do the motion capture things, I was like, well, let's just like basically print out a glyph and stick it to the box's back, and then we can get 6 degrees of freedom from that tracking glyph, 1 camera per boxer, and we can use that to map it to the robot's upper body, because the robot's not going to really move that much. It's not going to have legs, for example, so we really have to only model those upper body movements. So I wanted to use some pretty decent cameras because I wasn't sure what kind of lighting conditions we'd have in the boxing ring, so I got these IDS micro eyes. They're industrial machine vision cameras that were regular USB, pretty nice cameras, C-mount lenses, so we could change lenses out later. And it was a straight up AR toolkit implementation. And then basically assembled up a queue of motions and then sent them down the line to a embedded pneumatics controller that was a standard industrial controller that the special effects people use all the time. So it was like a PLC plus a pneumatics matrix, and we would just assemble up a big UDP packet of all the latest movements and send it down the line.
Yeah, that part was pretty cool. I'd never seen that stuff before, so it actually really was an educational process. Of course, you have to have a scoring system for boxing, and we decided to make these giant healthometers, basically like, for like starting blocks of a drag race or something like that. So we had a bunch of bulbs, 120 volts. We had a bunch of solid-state relays and a basic stamp, from Parallax, and they're another company that sponsored us on the show, so we got a ton of stuff from Parallax, who specializes in like hobbyist robotics, and then from Freescale. So we had a basic stamp, sort of like it was before Arduino. Everyone asked me like, how come you don't use Arduino? And it's like, well, it didn't really exist when we were doing the show. And just a bunch of solid state relays, and we had a Hall effect sensor on the back of the robot's neck and a magnet on the back of the robot's neck. So as the robot got punched in the head, the neck would go back, and the Hall effect sensor would detect the magnetic field, and if it was close enough, then it would deduct a point from the system. So it was just a little kind of nice addition. Oh, we also sent the current score over to Zoz through serial port, just so he could keep track of that with the control software to stop the fighting after the fight was over. Okay, so we have
once all the health was gone on a robot, it entered like a pre-planned sequence where the robot would go through this death movement, and the other robot would exalt. So you had to know when one robot had won.
Oh yeah, I forgot about that, the death sort of thing. Okay, so we have two videos here. I don't have audio hooked up, so I'm just gonna hold my microphone up to the speaker. But this one is just a demo at sort of a medium speed of the robots kind of duking it out before the show. So it's pretty cool. And so after we did all that testing, we figured, well, after all this fighting, they need to make up a little bit.
There's nothing I like better than robot porn.
No one has seen this video before.
Family show, guys. Come on.
No, robots fucking is pretty awesome. This isn't being recorded, is it?
Pretty good, huh? You got your picture?
Yeah, robots are amazing. Okay, next one, traffic busting truck. This was basically a car that could elevate itself and drive over traffic and move in any direction, so it could like slide in between parking spots and everything. And just another one of these giant builds, like, lots of steel and stuff to look cool. But actually it turned out, this was our second one, it actually turned out to be, I think, one of my favorites, definitely.
Yeah, I'd written up this a while back and not really ever decided on how it should be done. And so we went into it, mechanically speaking, really not knowing what we were going to do. But basically the idea was we wanted to have some kind of pickup truck that had an assembly in the bed that could unfold and allow it to elevate up. And it had to be able to do three different things. It had to be able to park by itself. So by pressing a button, it would slide into a parking spot. So it had to be able to have a drive system that could slide as well as go forward and backwards. And then it had to be able to jack itself up and drive itself over another car to get out of traffic. And then if you couldn't find a parking spot, it had to be able to jack itself up and park over the top of another car. So there was some pretty serious mechanical elements that had to be done, and as well as some sensing and software to do the autonomous parking.
Yeah, there was a bunch of control stuff as well. So it sort of had these three phases of, we first needed to find these omnidirectional wheels. We needed to figure out a way to control them, and then we needed to figure out a way to make them intelligent. So it was this kind of multi-phase thing. We ended up using a wheel from a company called Omnitrax?
AirTrax.
Oh, AirTrax. And they had licensed the technology from the United States Navy, which was a Mecanum wheel that allows a system to move in any direction. They design forklifts to move weapons on aircraft carriers, so in very small spaces.
Yeah, they actually went out of business shortly after
Did they really?
we did the show. Yeah, so that's why the forklift never went back to them. And actually, we identified the wheels that we wanted to use, and in that size, they're basically the only ones that make them. And they said, sure, A, we'll send you a forklift that you can use for the whole show and be promotional for AirTrax, but B, we'll send you these wheel modules. And what they were was these big Mecanum wheels attached to a servo and a controller in a big metal box. So each wheel assembly weighed something like 400 or 500 pounds and had everything it needed to do to move, and you communicated it with it over CAN bus. And we found out later that what they had sent us were these 4 wheel assemblies that were their original prototype wheels when they were first starting the company, and they'd been in a box somewhere in a closet and no one had touched them in forever. So they were just these big wheel modules, a huge rat's nest of wiring, and some vague instructions on how to use them, how to communicate with the 4 of them over CAN bus. And then also what really kind of saved us was the fact that there was a separate control box module that you could talk to with a plus or minus 5 volts joystick controller.
Yeah, so it took the guys from AirTrax 2 days to deal with all the rat's nest of wires. But then at that point, they're like, all right, you just need, plus or minus 5 for forwards or backwards, plus or minus 5 for left and right. So I wired up a bunch of circuitry on a board, again, another basic stamp, and a wireless PlayStation 2 controller, so we could wirelessly control it for testing. And then
it was actually really funny with that, because once we found out there was a standard analog joystick signal input, Joe said, oh, let's use the wireless PS2 controller. That's really hackable. It's a classic. We'll just figure that out. Got a rat's nest version working, so long before this final circuit board was printed. And the guys who came over from Airtracks to kind of monitor what was going on and help set it up were just like, whoa, we've got guys back at the shop that spent months trying to do this, and you just did it in like a day.
Yeah, we really threw it together. And then we had digital potentiometers, which would basically, from the basic stamp, would adjust the digital pots, which basically would give you kind of, pretty good resolution of analogness. What we didn't realize until later is, so these things are super dangerous and very heavy, and when they're on a car or a truck, even more dangerous. It turns out that if these controllers that we were attaching to lost their analog signals for the joystick, the system would just go berserk and just like run the wheels at full speed or do something. So we were like, we didn't know this until later, but luckily Kevin, one of the guys who was originally on the show and became a guest builder, a machinist, insisted on having a kill switch. And I'm like, come on, we don't need a kill switch for this thing. Like, nothing's gonna happen. And luckily we had it because he had done this type of stuff before.
There was also some kind of race condition in the hardware of the Airtracks wheels because occasionally it would require the double reboot.
Yeah, oh, that's right. Wow. Oh, memories. Okay, so for the sensors.
Yeah, there's a lot of ways we could have done the autonomous parking. It was, a fairly straightforward problem because we had the ability to crab sideways as well as move forward backwards, so we didn't have to do the whole kind of like reverse parallel parking. That's a pain in the ass, which is why you want autonomous parking in the first place. So we really just wanted to feature a lot of sensors because we, basically it became clear early on to Joe and I that to get technical information into the show, we had to be subversive about it and like basically get it in under the radar because they were quite happy to gloss over all that stuff. So we basically said that we needed all these sensors when we really could have done it with probably with just one. But what we ended up doing, just to show off a few things that we could do, we had a couple of linear rangefinder sensors. So we had the infrared sensors, the Sharp, the standard Sharp IR hobby sensors that you can get from anywhere now. And the parallax ping ultrasonic sensors. And then I had done a lot of stereo vision work and had used these Vidiri design sort of system on a chip cameras a lot of times, and I wanted to feature them. So we got their latest and greatest at the time. They sent this one, it wasn't even released yet. It was called the Stoke, and I can't remember what that stands for now. Stereo on a chip, I think. But basically it had a custom FPGA inside that did all the stereo correlation. It was a Firewire camera. And what you got out of it from your Firewire connection was just full 60 hertz RGB in depth for every pixel in like a 720 by 480 or something like that, whatever 640 by 480. So that was really cool. They hadn't even released it yet. And so how we kind of ended up divvying up the tasks was we would use the infrared to detect gaps between parked cars as it drove forwards, and then use the stereo to, because you got that nice 2D depth map, to align the vehicle so it could slide in, and then it would slide in until it got a reading from the parallax ultrasonic sensor.
Which was for the curb. So when it got to the curb, it knew that it was there. So here's actually a demo of that. We built an autonomous couch while Kevin and Terry and the other guys were working on the the real truck with the real frame. We built it on a couch. We drove this couch around Treasure Island where we filmed, and it was really awesome. So here's the first test of the autonomous, or maybe not the first test, but the day we succeeded with the autonomous.
This was before
couch.
It got captured on the real cameras.
Yeah. This was
your handheld camera.
I filmed a bunch of stuff, and the producers got really mad because they're like, "You're supposed to be on camera, not filming." But I knew that if I didn't, none of this stuff would exist. So I filmed this, and right after this, I think I had to leave and go straight to my honeymoon in Italy and finish the DEF CON badge. So here's the. Here we go.
Ready? All right, Zoz, hit it.
I don't know if we mentioned, but the test rig we used was a couch. So we put the 4 Airtrack wheels on a metal frame and put a couch on it because the main rig wasn't ready yet.
So the IR just detected that gap, and now the stereo cameras are aligned itself, sliding in, and then the ultrasonic will detect when we're at the curb. And now we're at the curb. Thanks. And here's a picture of the truck over another car, which was actually our car, and it was the smallest rental car that we could get with the most insurance that we could get. because we had no idea what would happen. We did all sorts of other tests on it, and the only thing that happened was like a tiny little bit of grease from one of the wheels got on it. Right after we took this was when the police guy came by, right?
Yeah, we were standing there, doing our kind of triumphal photos and joking about, is this a legal parking spot or not? And as luck would have it, right at that moment, the San Francisco Police Department parking inspector rolled up. And so we got him on camera and we joked around and asked if it was a legal parking job. And he sort of measured how far it was from the curb and said, yep, all right, that's legal.
Yeah. He's like, I don't think we have any laws about parking over another car. So that was sort of fun. Mind control car, AKA
anger management. So this is something where I have to really try hard to manage my anger, because we had written up this episode. We'd done a long break after, I can't remember which episode, but there'd been a sort of long gap where there was a changeover in management at Discovery, and they had to kind of, make sure the show continued. There was a lot of political stuff at work. So this was the first one we filmed after the new management at Discovery. And we had written up this whole thing, which was that we were going to develop a therapy system for anger management for people who had road rage, right? So if you had road rage and it was a problem, you would go to this therapy session and you would take part in a remote-controlled demolition derby, where if you got too angry, your car would shut down and you couldn't do well in the demolition derby. And so it kind of made sense, right? It seemed cool. Then when they actually edited the show and they put it together, they constantly were doing this voiceover saying, in the future, this will be used to shut your car down if you get too angry on the road. And it's like, no, that'll just make you more angry. And people came up to us constantly after this. They're like, that's a really stupid idea, guys, because your car shutting down when you get angry is just going to make you more angry. It's like, yeah, we fucking know that. That's why we didn't design that in the first place. It was all a therapy session.
Yeah, this episode, I nearly quit every day, and Zoz was like, come on, man, just one more day. There was a lot of other stuff. They had hired an additional person for the show. I won't get into that too much, but let's just say that she didn't end up making it into the episode, except for one final scene. If you watch carefully at the demolition derby at the end of the episode, you'll see her walking across, and people are like, who is that person? So yeah, it just totally sucked. But luckily I held on. Zoz was like, just one more day, man, you can do it, and it sucked. So this reminded me of why I hate working for people.
But the idea basically came because people had been doing a lot of, or at least brain-machine interfaces were in the news a lot at that time. And there were a couple of companies that were developing chipsets for doing EEG-based headsets. So one of them is the one that, and we went to visit them and we tried their system. It was NeuroSky, and their chipset is in most of the sort of consumer-level EEG headsets that you find now, like the Star Wars Force Trainer. It's like this little headset you wear and you concentrate and a fan blows a ping pong ball up and stuff like that. They're in a lot of things. And then there's this other company that had just moved from Australia to San Francisco called Emotive that was doing this multiple electrode EEG system that could detect concentration levels and stuff like that, and it also could detect facial expressions based on the electrical signals from the facial muscles. And then the thing that really excited everyone about it was that they had some kind of classifier, which they wouldn't say what it was, but it was probably some kind of support vector machine on the 10 electrodes where you could train it by concentrating on a certain specific thing, and then you could do recognition on that later. So you could train it on this one thing, and then when you thought about that thing again later, an action would take place in software. So it was kind of like a mind control system.
Which is what we ultimately ended up using that part for. So the whole concept of this, after they totally edited the hell out of it, the episode ended up being an anger management demolition derby, but basically you had different biofeedback that would affect how you could control the car, and if you got too angry, it would stop, and you had to use the emotive to start the car and stuff. But it was fun. It was just a total clusterfuck. It didn't really make a lot of sense, but it was great to work on some of this stuff. It was kind of fun. So here are just some pictures. We had instrumented each car. We each got to pick a car from the junkyard and instrumented with a bunch of remote control stuff. So using, standard RC plane remote, kind of hobbyist remote control. Each one was individually controlled, which was time consuming, but not, very special from the special effects point of view. But remotely controlling them with a computer is what ended up being really difficult. So I'm sure Zoz will have something to say about that. The first part of the control system, we had a PlayStation 2 driving controller, so not a wireless one, but an actual steering wheel for each person, and we had some circuitry, another basic stamp, a Lantronix export, so we could send serial data to this device, and it would just send, I think, everything over UDP to Zoz. So Zoz was getting the data once I sort of processed it for direction of steering wheel and brake and shifting and stuff. I had an on-screen display, so we had a camera mounted on each car so we could see the car's eye view, and then an on-screen display that would display all of the information for each player. We had an electric shockerator that we didn't end up using, but that was supposed to be like if you got too agitated, you'd get an actual electric shock. But we, for some reason, we didn't use it, but we ended up just shocking each other. Zoz shocked my ass, and we shocked Mike North while he was lying down. So it was pretty fun. But all of the data that I was processing from the PS2 controller and I forget what else went over to Zoz, and then he took all the rest of the stuff and ended up remotely controlling the cars at that point.
Yeah, what was exciting about a lot of these things for us was that we got to mix the things that we knew how to do already with things that we hadn't really done, at least on that kind of scale. So in particular, getting to play with one of these pre-release headsets. This hadn't been released yet. One of the reasons we chose Emotive instead of NeuroSky is we went to visit NeuroSky and tried their system, and it worked really well, single electrode. But we got the sense that when we told them that we needed 4 headsets to control the four cars, they kind of blanched and looked a bit weird, and we got the sense that they only had like maybe 1 or 2 prototypes, and they couldn't even give us 4. And Emotive was the same too, that they were really at the prototype level. They had a few headsets, but there were a lot of bugs that hadn't been worked out yet. So that was fun, and then also just getting to work with big metal things like full-size cars and remote controlling them. It's just like not something you get to do every day. So the NeuroSky headset, I talked about that a little bit, and the Emotive headset, they only had a few prototypes, but we had a lot of places in the show, we had a lot of trouble not only kind of figuring out how we would explain to the audience what was going on, but how we would explain to the production company what we were going to do as well, because they really couldn't understand a lot of things. Like I had to explain maybe 18 or 20 times how the augmented reality stuff worked and optical glyph tracking, but to the production people, so they would even know how to film it. So we had by now started to sort of get good at coming up with intuitive demos to just sort of describe what the hell was going on. So what we came up with the Emotive headset was, well, what do people think of when they think of like telekinesis and mental powers? Uri Geller and bending the spoon. So we came up with the good old spoon bending test.
Yeah, and you'll see a lot of these types of videos in the show, and it's basically like, how can we explain technical stuff to our grandparents? And if they can understand it, then the production company can too.
Here's how this test is going to work. I'm going to be concentrating with the Emotive controller to push that cube on the screen. When I push that cube, it's going to send an event to my code, which is going to send an electrical signal along these wires, which is going to talk to this servo controller, which will turn on this E switch, which will send power to this actuator, which will bend this spoon. The good old spoon bending.
Oh, I guess that's all. I don't think we showed the whole thing. Yeah.
Yeah, the whole thing's kind of long because it was actually really hard to concentrate and get the mind control system to match.
Well, I kept saying stuff. I remember.
Joe was like,
you can do
encouraging
it.
me and
You can
egging
do
me
it.
on, but it was just really
He's
distracting.
like, shut up.
Anyway, the spoon
so-
gets bent eventually.
And this project was probably one of the most software heavy, I think, because you had the Emotive stuff, and then you had your multi-threaded system to take in all my data and control remote control cars. So this was another one of the podcasts that's probably one of the best. We call them podcasts, but they're part of the show.
Yeah, so the other part of this, we had this whole biofeedback system from some other company that was making biomonitoring stuff, mostly biomonitoring hardware, but they did galvanic skin response and heart rate and stuff like that. So I was getting a bunch of signals in from their stuff. I had to do heart rate detection because what we heard was one measure of agitation was not necessarily your direct heart rate, but the variability in your heart rate, and apparently high variability is good. If your heart rate becomes extremely regular, that means that you're actually under stress, or something like that. I don't remember. Anyway, I had to do some digital filtering to pull out a really reliable heart rate timing information. And then all of this was going out to a regular Futaba remote radio control receiver through this device that's sold by some hobbyist. It's a USB to Futaba interface called the PCTX, which works great if you only have one of them, but once you have a whole bunch of them and you're using Windows, you're in the usual hell that you're in whenever you use Windows for anything hardware related. So after all of this, there was like all this complicated shit, and I really wanted to explain to the viewer at least something about what the hell was going on with this, because I thought we'd conquered a lot of obstacles and come up with a fairly elegant solution. So I really pushed hard to be able to do, they gave me 1 minute out of the episode, which they then cut down to less than a minute, but they originally gave me 1 minute to explain the sort of high-level architecture of how the software worked. And I had written this thing because I'd written a multi-threaded driver for all this stuff, because there were all these different pieces of hardware I had to talk to, and I really wanted to explain how the multi-threaded system worked. And so I came up with this idea where I would use Joe to represent each thread, and we would do a 4-way split screen. So we have to lock off the camera and film it one at a time, all these 4 things, and we have to be super careful that Joe doesn't stray into the, where all the cutoff lines are. And they said, this is ridiculous, this is going to take so much time, like, you can't do it. And I fought them hard, and they eventually let me do it. And it became one of the most popular technical segments when it finally got edited, because it's like, how often can you turn on the TV and hear about code multi-threading? Not very freaking often.
No. That's where my acting skills came in, to stay in one spot. That's hard to do.
An inside look at computer coding.
Right now, Zoz is coding. It might look like he's just playing around on the keyboard, but he's actually writing specialized programs that are going to tie all of these different parts of the build together. It's pretty complicated stuff. So for a little better explanation, some more detail about how everything really works, I present to you the Code Master.
There's a lot of custom code that has to be written to get this anger management system to work. That's why you see me typing all the time. Code is a written set of instructions that tells a computer what to do, and I'm the one that has to write it. My code is made up of threads. A thread is like a little program that runs inside a larger one. There can be a bunch of threads, like Joe here, but they all run independently to perform a specific task. In this system, each car is controlled by 4 threads. A game controller thread, which takes data from the steering wheel and pedals. A biopack thread, which reads the driver's heart rate and perspiration level to regulate the car's performance. An emotive, or mind control thread, which controls the car's transmission. And a car controller thread. So let's say the driver puts the pedal to the metal. A signal gets sent to the game controller thread, telling it to hit the gas. At the same time, the biopack thread is also getting data from the driver's body, measuring heart rate and perspiration or galvanic skin response. At the same time as this, the emotive thread processes events from the emotive system and decides whether or not the car should be put into forward gear. Finally, the car controller thread looks at everything the other threads have produced and decides what to do with the car. If the driver's brainwaves are calm and focused, and their heart rate is good, and their perspiration level shows they're cool and collected, the car controller thread puts the car in gear and hits the gas. But if the biopack and emotive threads show agitation, then the car controller thread will slow things down because the driver's getting too stressed. This is all just for one car. For 4 cars all working together, that's going to be a lot of threads. And if I can't get all those threads to work together, we're going to be dead in the water. So I had to re-record the voiceover for that stuff, like about 10 or 12 times, because, for example, I couldn't just call it the emotive thread. Like the Discovery decided, well, it's got to be the emotive or mind control thread, because people could still be getting confused. And of course, you have to have a cliffhanger at the end. Like, if it can't work, well, of course it's going to freaking work. I'm writing it to work, but anyway.
And here's a video of some testing. So once we got everything working, we were working with one car in the big warehouse, and we decided to let our producer drive the car. So again, I'm filming it. And this is where we realized how dangerous cars really are. So when Zoz, in his autonomous vehicle talk earlier today, it's hard to really understand, like, oh, robots are, driving these giant cars or whatever. But this is like pretty freaky when it's coming at you and no one's in it. So there's foot pedals down at the bottom. You can't really see them, but the guy in the big red chair is driving. Camera guy was fearless. He didn't even move. Our sound girl was sort of moving back, but I just realized he didn't even move. He was Australian, wasn't he? All right, I think this is the final one. Oh, no, there's actually two more. Okay,
How are we doing for time?
good, we're good, we're good. Okay, water slide simulator, 30-foot giant computer-controlled water slide simulator. This one, yeah, used real water. It took a really long time, and I didn't really do much. Zoz did some coding. I cut some steel and pretended to do some work on the show, but there really wasn't that much for me to do, which was totally fine. But this one required like real structural mechanical engineering. So we had a company called Acorn do the original CAD design, do the finite element analysis, and make sure that it was actually a safe structure that we could then go and build. And then we basically had, I don't know, 50
Yeah, so this was
artists.
this was an episode. You know, we were in a really kind of desperate state a lot of times during the show, trying to get ideas approved. We actually ended up submitting 500 ideas to Discovery to get our 13 show ideas approved. We really had a lot of trouble, and so there was a long period where, you know, we were just throwing anything against the wall to see what sticks. And I had written over one weekend this idea of like a never-ending water slide that would, you know, have some kind of element that would spin and let you ride it forever. And that eventually got refined into the water slide simulator, and the network approved it, which meant we had to do it, even though no one had really done any cost estimation or time estimation about what it was going to take. So once they approved it, and basically we'd said, you know, the production company had said they could do it, but they didn't really know we could, and we had to look into it, it was kind of panic zone, because like I said, $12,000 per episode. The steel alone for this project cost $25,000. There was absolutely no way it was going to get put together in 2 weeks. So we allocated actually 4 weeks. It ended up being 5. Of course, if you watch the episode, the TV totally lies and said it was 2 weeks. But we were very upfront about it when we were filming it. We said this is how the 4-week breakdown is going to go, and then it ended up running over into 5. But it meant we really had to have this design support. So we partnered up. We talked to a lot of San Francisco area design companies, and we partnered up with Acorn, and they started to come up with these concepts and start doing finite element analysis on it. And at a certain point in the process, you know, it was like well into it, but before we'd started the construction, one of the people who were going to be project managing all this giant team of welders that we had asked the Acorn people, like, what's the biggest thing that you guys ever designed? And one of the guys was like, oh, well, we designed a workstation-sized computer case once. So this was like a lot bigger than anything they'd ever designed before. But this really goes to show that engineering is a bunch of principles that work, because it didn't matter that they'd never built anything this big before, because finite element analysis works. They were able to model this up and do FEA and be very convinced that the thing wasn't going to completely fall apart when it got built, and it didn't.
So part of this, there was really water inside, and we had a projector projecting the 3D image of the water slide on there. And I think the ride lasted a minute and a half or something, which, you know, most water slide rides take about 20 seconds and you're done. So this was really an amazing ride. This was actually my favorite build to experience, especially once the camera turned off. But there was a lot of software on this that sort of never really got the credit, but
Yeah.
cool graphics.
It was a tough thing from the software side, because so we partnered up with this company called Splashtacular, which is the only remaining North American manufacturer of water slides, because liability concerns have pushed a lot of that stuff out of the country because people get sued a lot in the United States. So they're the last ones. And when they design a water slide, they very, very heavily simulate it to make sure that they know that no one's ever going to fly out of the slide or, you know, undergo anything that could cause an injury that they might get sued for. So they use a piece of simulation software that NASA developed called NASTRAN, and they do all of this this hardcore simulation on it. But we were trying to do this slide that was 3,600, you know, the virtual slide. If you were to build it for real, it would be 3,600 feet long of linear slide, and I worked out that it's about the same as the the height of the slide would be about the same as the towers on the Golden Gate Bridge in San Francisco, right? So this is the kind of slide that you probably could build if you were some kind of like, oil baron or something like that, but it would be very expensive and difficult to build. So they ran their NASTRAN simulation on it when we started the FEA simulation on the actual simulator, which happened about a month before the assembly started. The NASTRAN simulation ran on one of their computer clusters for that entire month and then crashed and didn't converge. So we had I was planning to use the output of the Nastran simulation to drive the access controls of the actual physical simulator itself. So a month went by, it crashed, returned no useful data, and they said, well, we can try running it again. And I'm like, what? And another month, I'm going to get nothing out of it either, so we're going to have to go to plan B. So what we did was just make a virtual fly-through of that 3,600-foot slide. And what you see up there, one is the POV of the camera that's doing the fly-through, and on the right is the external view of what that slide would really look like from overhead view and side view. And from the 6-axis fly-through, I could get everything that I needed in terms of the degrees of freedom mapping to the actual simulator. I couldn't have like any kind of real acceleration data, but I could do some finite differences analysis of that 6 DOF camera data and get something that was basically close enough. Like it wouldn't necessarily, if you were to put like an accelerometer on that thing, it wouldn't necessarily feel exactly the same as the real slide, but coupled with that visual representation that you were seeing as you went down the slide, it was good enough.
It felt pretty real. So yeah, so this thing didn't just spin, it could move up and down, tilt left and right, and speed up and slow down. So it actually did feel like you were riding it. I think our stomach muscles hurt for a few days just laughing at how much fun it was. Lots and lots of steel, the motion controller, 6 axes they're all hydraulic based.
Yeah, this is just another example of something that was just really exciting and terrifying to us because, I mean, this was real heavy metal, right? This is like a giant steel thing that was much bigger than anyone had built before and had the capability to completely tear itself apart from the strength of its own hydraulic actuators.
Yeah, and it probably almost did. So, oh yeah, more software stuff. You can explain this.
Yeah, I don't know. We just got a 10-minute warning. So basically, I did a B-spline interpolation of all that camera motion axis, downloaded it to this RMC motion controller. So this was like a thing that we really didn't know a lot about. It was this black box motion controller designed for the hydraulics industry. What was great was that there was this, and for all the people that are interested in doing like SCADA attacks and stuff like that, this is pretty interesting because this RMC 150 had this facility where you could send it UDP packets and the contents of those packets would be directly written to the registers inside the RMC 150, right? There was absolutely no checking of anything whatsoever. So if you know about this protocol, you can basically send a network packet to this hydraulic system and it will just set register values and tell controllers what to do. So I'm sure there's a lot of industrial systems that are out there like this.
I know a guy that has the code for that,
This was all documented, so it was, we didn't have to find out any secrets. It was in the operations manual, and that just made my life easy. I could just craft a particular UDP packet and write to those registers, and then I had, I wrote the interface in the user interface and the visualization stuff in Java because it was really easy to deal with on the Mac with all the video stuff.
I like you have to justify the use of Java. Okay, so the final one for today anyway is the Flying Lifeguard. This was an attempt to create some life-saving vehicles for the ocean, for unmanned beaches. You had a short-range cannon that would basically shoot a life preserver to somebody in the surf zone, and then you had the UAV, the airplane that would fly. Zoz showed a few pictures of that in his presentation earlier, that would launch off of a rail and fly further out and then drop a life jacket. It was actually a water-activated life jacket, so it would hit the water and then sort of inflate.
And then what I didn't mention this morning was that in addition to the long-range life jacket deliverer, so if you're out like well past the surf zone, that we had a secondary thing. If you're in the surf zone close to the receiver, it would actually fire a life jacket to you out of an air cannon, just like a big mortar projectile, and it would land right next to you, hopefully, and not in your head, and inflate, and you'd have a life jacket.
Yeah, so it was cool. This was one that, in theory could have been actually useful. So the first thing we had is for the swimmer in distress, you'd have to wear some sort of GPS beacon, and ours was gigantic because we didn't have the time to sort of shrink it down. And even back then, there weren't very small GPS receiver modules available for cheap. So we basically had a basic stamp and a GPS module that would just parse the NMEA data when the red button was pressed, and then send that using an Aerocom RF transceiver module, just a generic kind of RF transceiver, serial data in, 400 and something megahertz out, or maybe it was 900 megahertz out, send that to the receiver, which was connected to your machine, which would then either fire the cannon or make adjustments with anemometer and other stuff we'll talk about, or launch the plane.
Yeah, and this was 2007, 2008, I can't remember one of those 2 years, and 3D printers obviously were around, but we hadn't had the kind of revolution in home 3D printing yet. There were RepRap and stuff were around, but not a lot of people knew about them yet. And so when we first were putting the show together, I said to the producers, we've got to have a 3D printer. Like pretty much everyone else at that time, they said, what the hell is that? So I talked to Z-Corp and got them to give us a 3D printer. And this was sort of one of the first times we were able to feature 3D printing to a mass audience. And it was really super convenient because from a fabrication point of view, Joe could give me the circuits that he'd prototyped, and I could take physical measurements off them, design something in Rhino, just put some cutouts for the circuitry, print it out on the Z-Corp machine, epoxy infiltrate it, and have a strong waterproof enclosure done basically inside of a day. And that was something that really hadn't been showcased before at that time.
Yeah, and it was pretty cool. So on the receiver side for the Canon, we had to do a whole custom receiver where we were measuring wind speed, wind direction, and then, wind speed, wind direction, and then we also needed to know the GPS location of the cannon so we could do a bunch of calculations and figure out where the cannon was in relation to the person in distress, take the wind measurements, make the pressure adjustments to the cannon, and then launch it. So we had this sort of intermediate system. This was receiving the data from a transmitter, displaying the cannon coordinates, the target coordinates, the wind measurements, and then all of that stuff was going through the Lantronix export over to Zoz, who would then do the final control. So that was kind of a fun circuit to throw together. We didn't have time to make a board or anything. You know, for this type of stuff, it wasn't worth it most of the time because people weren't going to film it anyway. We normally had the camera guys walk away when I started soldering.
It turned out we would have had time to spin up a board for this, but we didn't know that we did, but we just kept crashing planes. So what started out as a 2-week build ended up being 4, just because planes kept crashing, and this guy, Steve Leshevsky, that helped us out, just would build a new plane every night. Yeah.
So for the airplane side, for the UAV, this was like right before a lot of the hobbyist-based UAVs were coming out, before quadcopters really. So, you know, the only real solution we had, we thought, was this airplane. And autonomous airplanes seem really hard. And at first we're like, oh, well, we have Steve Leshevsky. He's a hobbyist. He flies lots of airplanes. Should be totally fine. And it probably would have been, but we ended up hitting some power lines first, and then the whole build just went downhill from there. It was really, really stressful. A lot of RC plane fields that where you would go to fly your remote control planes did not like having us there, did not like having cameras there, did not like having autonomous flying robotic vehicles. So it was really challenging. There was one company called Micropilot who made a UAV module that we were able to use and then modify some of their software. And we had set up a GPS waypoint for the airplane to fly to and drop the life jacket and everything. But Zoz talked a little bit about it in the earlier presentation. But it was just very hard to get the timing just right for that. Here's sort of some videos of the cannon and airplane.
On the left is some high-speed footage of the air cannon firing, just doing a speed test with the, you know, for TV you've got to build a giant ruler if you want to do a speed test. You can't just do it in some kind of sensible fashion. So basically, what would happen is I'd get this GPS transmission, map those latitude and longitudes to the WGS-84 ellipsoid. One thing I forgot to do until we tested a few times was do any kind of magnetic true north calculation, because I basically was like, you know, how different can it be in San Francisco? It turns out it's 17 degrees, so it is pretty different. So I was like, oh, this cannon's always firing quite a long way off axis. And then we were modulating the pressure in the air cannon to get changes in distance. So we had a fixed elevation of the cannon and then just modulated the pressure. And we had an anemometer. You can actually see, if you look in your BruCON guide, you can see an awesome photo in Joe Grand's profile of Joe wearing the anemometer weather station on his head.
It's the only way I could get any camera time on this show. Oh yeah, we almost killed the camera guy on this one too, and we were doing some testing of the cannon and stuff, and I was sitting out in the field, and you know, Zoz and the other guys were shooting the cannons to see how close they could get before we went into the water. And I was supposed to, you know, be looking out and seeing if the cannon was coming, and if it was, or if the life jacket was coming. If it was, I was supposed to tell the camera guy because his back was to the cannon. And it came so close to me, I was laughing so hard that I forgot to tell the guy. and it came within like, I don't know, a few feet or something and slammed down. He got super angry, but it was totally awesome.
And then here on the right, you can see our solution for launching the plane. It was a combination rocket and rubber bungee slingshot so that we could get a really, really short takeoff out of this thing. And what you're seeing here post-launch is in the bomb bay where the life jacket would normally go, we stuck a HD camera in and fired it off to sea to get some footage of it. And it really kind of brought home, I guess, a mental transition in us. We'd started this project off just kind of like, you know, having to put on our brown trousers because we were just shooting ourselves with whether this was going to work or not and whether we could do it. And then making some progress and crashing a lot of planes, though, and feeling really nervous about, you know, feeling like we could actually do it if we could just keep a plane in one piece for long enough. And then at the end of it, just putting like one of the most expensive cameras we had into it and just like letting it go out a kilometer out to sea and just trusting it to come back because it turned out to be really, really reliable.
Yeah, we didn't pay attention to it at all. It was, pretty funny. It wasn't our camera anyway, so it wouldn't have mattered.
And the biggest challenge from the software side was just dealing with what I mentioned earlier this morning, the latency and unknown time stamping of the GPS data. So basically, the plane was in an unknown 70-meter region when it was doing its bombing run when you had to drop, and we wanted to drop it inside like a 5-meter radius circle. So I had to write a custom plugin for Micropilot's base station software called Horizon that would do some prediction and just try and get it right. We also there was just a lot of trial and error on what the ideal approach path was. We tried, high altitude drops. We tried drops with parachutes. We tried like Mark 82 retarded bomb style things where they would deploy like a really small drogue chute when it came out and do like low level bombing runs. And we eventually just kind of came up with something where everything pretty much worked together.
Yeah, it was actually, without spoiling the show, you should really watch the show because it worked. It was awesome. Good, so that's actually all we have. Thank you. You guys have any questions? No? Okay. Cool.
Great,
Thanks.
well, thank you for watching.
Oh, there is, we do have a question. So one, we talked about one episode that took 5 weeks, and the TV guy said 2. It didn't happen very often, but the problem is that we didn't have any editorial control. There was a few times where Zoz and I were given like a review so we could technically review the show, but we came back with so many comments that they just ignored it and basically wouldn't. And they didn't really care about, we were because we're hackers, we're very open, we want to share all of, our documentation and information and stuff, which most of the electronic stuff is on my website. But the production company didn't care, right? Like they just make TV. They're like, well, what's the difference if it's really 5 weeks, but we say 2, it's going to be more dramatic that way. So we just had no control whatsoever. And when you read a lot of the comments, on whatever /dot about the show, people are like, how come they didn't blah, 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 blah. And it's like, because we don't really have control now. Like we're just disposable talent.
The 2 ones that went majorly over time were the waterslide simulator, which ended up being 5 weeks of filming. So 5 weeks after the FEA was done, and the life-saving drone, because that was supposed to be 2 weeks. We thought we had basically everything we needed to do that in 2 weeks. Once we had the micropilot on hand and everything like that, and then we just kept crashing planes, so it ended up being 4 weeks.
Well, and the 6x6 all-terrain vehicle, which we didn't talk about, but we ran out of time and then begged for more and got a little bit more.
But that one they did, they were honest about on the show. They showed that we had a cutoff and we didn't get it done, and then we got extra time afterwards. So that ended up being 2 separate 2-week things. And when we say 2 weeks, that means 2 weeks of filming time, so 14 shoot days. So in full elapsed time, it's like 2.5 weeks, because you've got like 2 5-week shoot days, and then you've got another 4 days the next week. Yeah, because the main expense that they have is shoot time, camera time, right? They weren't paying us very much. They were spending almost nothing on engineering. Their main expenses are camera time and post-production time. So what makes the show expensive is just having to pay all these camera people and sound people and all that kind of stuff.
And so we ended up, I forgot what I was going to say. But they canceled the show because it was too expensive. And I also remember. Yeah, so, they could make lots of shows about aliens and stuff like that, for a lot cheaper than they could make one of our episodes. What was I going to say? Yes, okay, so right, so we had to do the shooting during, we had to basically be on-screen hosts, and then we had to be real engineers. And then we had to sort of parse and dumb down our real engineering to be on the show. So it's almost like we were doing 2 jobs. And a lot of times, our producer would be like, okay, we're going to schedule when your next test is, ready to film. Zoz, are you going to be ready tomorrow? And it's like, you have to be ready tomorrow. So then Zoz would spend the rest of the night, getting it working off camera. So there was a lot of off-camera work just to get to the points where there was like little nuggets that they could film and put in the show.
Yeah, I pulled a lot of all-nighters on the show, and occasionally, they sort of talk about like, oh, someone's been up all night, and whenever they say that, it was definitely true.
Yeah. Cool. Anything else? If it was just me and Zoz. No, if they will never.
We did some development on a second season. We did about a month of development work, and we had 10 out of 13 ideas approved, which is better than we ever had on the first season. But we had a manifesto of demands as well for what it was going to take to get us to sign up for a second season.
Like lunch, breaks. Yeah, there were reasonable demands. It wasn't we wanted green M&Ms and stuff. But now we realize that, when you look at like rock star, rock bands that have riders of like, we want this, 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 and water in the dressing room and this and blah, 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 and lunch and this. There's a reason for that. It's not that they're all assholes and just, prima donnas, but it's because otherwise the producers would screw them, the promoters, the booking agent. It's all the same thing, like just entertainment in general. So we had reasonable demands. And that was just way out of what they're used to hearing.
Yeah, but so when they came back and they said the show is basically too expensive to make, so they came back and said, we want to do a show every I think like 7 filming days instead of 14 for the second season. And we said, no, actually, like top of our list of demands is like more time for it. And they said, well, it's too expensive. But it was sort of a relief because we didn't have to have a fight about that whole list of things. But at the same time, if they had agreed to that whole list of things, we definitely would have done it again.
Yeah, and it was also good. My son was born on the final episode of the show, so I'm sort of glad that it ended. I would definitely do something again, but now that we've gone through it once, we know what it really takes and would probably, definitely ask for more. But it was fun. It was a great experience. I mean, coming in from an engineering sort of hacker perspective and not growing up being like, I want to be on TV. It was a totally interesting experience. But I also learned a lot about the TV industry that I probably didn't want to know. And I can't watch TV anymore. I don't have a TV anymore. But you guys should all still watch the episodes.
The main thing is if you can ever get anyone to pay for you to build outrageous, crazy things, you should probably say yes. Because there's just no other way we would have got to work on such a just really bizarre and strange, eclectic collection of projects.
Well, now I think we probably have a lot of, I don't know about you, but I ended up with like 3 carloads full of stuff from the show, a PC board prototyping machine and all sorts of components and a new multimeter and a heads-up display and like all this stuff. So it was totally worth it from that too. It's like, every time a company goes out of business, you just totally pillage. And I shamelessly pillaged. The water slide got recycled. It got chopped down and recycled.
Yeah, so $25,000 it cost for the steel. They sold it for $1,500 in scrap.
Yeah, and we actually had tried to sell that back to Splashtacular as like a product that they could, put on cruise ships and stuff. And the CEO of the company actually came and wrote it and loved it, but they just thought it would be too much of a maintenance issue.
Yeah, they said, oh, it's really cool, but we just don't really think it's part of the core thing that we do at Splashtacular. But
he was probably right.
They're a conservative company, which is, I guess, what you end up being if you're the last manufacturer in a particular industry in that country.
Yeah, but I think a lot of this stuff could have been shown off at hacker conferences or Maker Faire and stuff like that to kind of show the whole do-it-yourself ethos. But the production company wasn't thinking that way, and we definitely didn't have the clout or the energy really to kind of push that. Anything else? No. All right. Enjoy your rest of BruCON. Thanks.